all know that for communicating a language is needed. That language can be a spoken language or it can even be a sign language. So you need some or the other language to communicate. You can communicate in different languages like Hindi, English, Chinese, Japanese, etc. Or if you are using sign languages, then with the help of actions, gestures, etc. you can communicate. In the same manner, computers also require a language to communicate so that they can process on the commands that are given to them and produce the output which is desired by the user. Hi everyone, I'm Megha and welcome to UGC NET with Megha. In this video, we are going to understand the number system that is covered under the unit Information and Communication Technology. So this number system holds a great importance if we talk about the paper 1 examination, because every year one question from the number system and its conversion is asked in the NET exams. There are 4 types of number systems which are used in computers as well, and these number systems are as follows. First is binary number system, second is decimal number system, third is octal number system, and fourth is hexadecimal number system. So now we are going to look into these number systems one by one. So the first number system here is binary. Bi, as the name suggests, means 2 digits. So this number system has a base of 2 and it includes only 2 digits, that is 0 and 1. And this binary number system is the language of communication or the basic language in which the computer communicates and processes the commands and generates the desired result. The next number system is the decimal number system. So as the word in this number system, that is deca, suggests 10. That means deca means 10. So here the base is 10 and this number system includes digits right from 0 to 9, and this is the number system that we use in our day-to-day life for every single purpose, whether it is for valuation, for measurements, or for solving mathematical problems. The third is the octal number system. So octal, as the name suggests, has a base of 8. Octal means 8. So this number system particularly has a base of 8 and it includes digits right from 0 to 7. And the last type of number system that is in use for making various types of computer programs or for the various other problems which includes the involvement of number system is hexadecimal number system. Hexadecimal means 16. So the base of this number system is 16 and this number system is different from the other 3 number systems in a manner because it has a combination of both alphabets and numbers. So it is an alphanumeric number system, and here the digits from 0 to 9 are taken, and for the digits from 10 to 15 are represented by letters A to F. So now, before learning how to convert the numbers given in one number system to another number system, one thing that we are required to keep in mind is that while we are moving from one number system to another, we have to see what is the number system that has been given to us and in what number system we are required to move to. That is what would be the final answer. On the basis of that, we will be deciding whether we are supposed to divide or multiply. So the very first number system that we are going to take up, that is the first conversion that we are going to learn here, is from decimal to binary. So for going from decimal to binary, we need to divide, and this division will be by 2. So whatever would be the given number, that would be divided by 2 in order to come to the final answer, that is into the binary system. So the number that we are going to take up here is 90 to understand the conversion. So we will divide this number 90 by 2 till the number here in the dividend section is less than 2. So the first division would be that is 45 into 2 is 90. So here remainder would be 0. Next, if we divide 45 by 2, it would be 22 2s are 44. So here remainder would be 1 and 22. Now again 22 is divisible by 2 and it is fully divisible. That is 2 11s are 22. So here we'll get 0 as the remainder. Now when we further divide 11 by 2, it is 2 5s are 10, so we'll get remainder as 1 and 5 here. Now we'll be further dividing 5, so it is 2 2s are 4, so again we'll have remainder 1 and 2 here. So now these are equal, so still it is divisible, that is it is not less than 2, so we'll continue to divide. And this would be 2 1s are 2 and remainder 0, since it is fully divisible. So now the number here in the middle, that is the dividend, is 1, which is less than the number 2. So further division is not possible after this remainder here. So now for writing the final answer, that is writing the binary equivalent of the given number, we will be starting to take the digits from the very bottom, and the number which is no longer divisible is also considered for writing the answer. So from this bottom digit we will be moving to the top, that is we will be moving in the down to up direction, that is it is a bottoms up approach to write the answer. So binary equivalent for the number 90, which has a base 10, is 10111010. This is the binary equivalent for the number. The next type of conversion that we are going to understand here is from binary to decimal. So for moving from binary to decimal number system, we need to multiply by 2, and 2 would be assigned the powers starting from the extreme right, and we'll go from right to left, and the very first power that would be assigned to 2 is 0, and then we'll increase the powers in this manner, that is we'll move from the units place and reach the extreme left digit. So here we'll now simply below these numbers we'll write the powers that we are required to give to the digit 2, and then wherever the places there are 0, we can straight away eliminate the calculations, because we know anything raised to power anything, if multiplied by 0, the result would always be 0. So we'll only solve the values of 2 wherever we have the digit 1. So here the power, the very first power would be 0, the next power would be 1, the next after that is 2, 3, 4, 5 and 6. So now we are to solve for this first one, the third one, the fourth one and the sixth one, and the total of all these powers would give us the number 90. So now 2 raised to power 1 and multiplied by 1 is 2. Coming to the next digit, that is 2 raised to power 3. So 2 raised to power 3 is 8. So 8 multiplied by 1 is 8. Next is 2 raised to the power 4. So 2 raised to power 4 is 16. 16 multiplied by 1 is 16. Last that we need to solve is 2 raised to the power 6. So 2 raised to power 6 is 64, and 64 multiplied by 1 is 64. So now we'll simply add all these numbers and we'll get the final answer as 90. 64 plus 16 is 80, 80 plus 8 is 88, plus 2 is 90. So this is how we are going to undertake the conversions for binary to decimal. The next type of conversion that we are going to understand is from decimal to octal. So for moving from decimal to octal, we need to divide, and the number that we'll be using for dividing is 8. So that is, we will be dividing the given number by 8 in order to come to the final answer, and we'll continue to divide the given number by 8 till the number in the dividend column is less than 8. So let's take the same example, that is 90 base 10. And now we are going to convert it into octal number system. So for converting that, we'll divide 90 by 8 and we'll continue to divide till the number here in the dividend column is less than 8. So 88 would be the closest number that would be divisible by 8. That means 8 11s are 88. So we have the remainder 2 here. Now the next would be 8 1s are 8. Because it is divisible 1 times only, so 1s are 8, and since it is not fully divisible, so we have the remainder here 3, and now 1 is less than 8, so it is no longer divisible. Now again we will be following the same bottoms up approach to write the answer, that is the number which is no longer divisible. We will start from that number and move to the topmost value. So in this order we would be writing the answer, which is equals to 132 base 8. The next type of conversion that we are going to understand here is from octal to decimal. So while moving from octal to decimal number system, we need to multiply the given number by 8, and the 8 would be assigned powers starting from 0, and the assigning of powers would start from the extreme right position, that is from the units place, and then we'll move to the extreme left digit, that is we will be moving from right to left while assigning the powers, and as we move from right to left the powers would keep on increasing. So the very first part that we are going to assign is 2 into 8 raised to power 0 plus 3 into 8 raised to power 1 plus 1 into 8 raised to power 2. So now we know anything raised to power 0 is 1, and any number raised to power 1 is the number itself. So 8 ones are 8 and it would be multiplied by 3, and 8 ka square is 64. This would be multiplied by 1. So we'll have values 64 plus 24 which gives us 88 plus 2 which gives us the figure 90 which has a base of 10. The last type of conversion that we are going to look here is the conversion from decimal to hexadecimal. So here we would be dividing the number, that is the given number would be in decimal, so we'll be dividing it by 16 in order to come to the number in hexadecimal number system. But one thing that we need to keep in mind is that the numbers here after 9 are represented with the help of alphabets. So the final answer has to be replaced by alphabets if we have any number which is 10, 11, 12, 15 like that. So we need to replace that number by the respective alphabet. So the number that we are going to take for understanding this conversion is 102, and we have to divide it by 16 till we get the number in dividend section which is lesser than 16. So now 16 fives is 90, and the remainder that we have here is 12. So now we have the number, this number 5 in the dividend section which is smaller than 16, so no further division is possible. So the final answer again would be written with the help of bottoms up approach. So the final answer is 512. The answer that we have got with the help of bottoms up approach is 512, but we cannot write it as 512 because we know in hexadecimal system the numbers after 9 are represented with the alphabets right from A to F. So for 12 the representation is C, so the final answer here would be 5C raised to the base 16. The next type of numbers conversion that we are going to understand here is from hexadecimal to decimal. So for this type of conversion we will be multiplying the given number by 16. And the same would continue here also, that is 16 would be assigned the powers from 0, and this assigning would start from the extreme right digit and then we'll move towards the extreme left. But here one thing is little different. Here the digits which are represented alphabetically would be considered as one single digit, irrespective or unlike the other conversions wherein we have seen that one single digit was considered. Here C is representing 12. So 12 would be considered as one single digit and 16 would be assigned the very first power. That is 12 would be the extreme right for which we'll be assigning 16 the power of 0, and so on we'll be moving. So first we'll write it in this manner, that is 5 and 12. Now we'll start to assign the powers. So for 12 it is 16 raised to the power 0, and the next multiplication is 5 into 16 raised to power 1. So now anything raised to the power 0 is 1. So 12 ones is 12 and 16 raised to power 1 is 16. So 16 fives is 90. So 90 plus 12 is 102 with base 10. That was all for this video. The remaining number system conversions we are going to take up in the next video. Thank you for watching this video, and don't forget to like, share and subscribe. For further details on our online course, visit our website www.ugcnetwithmegha.com. The link for the website is given in the description below, and if you want me to cover a particular topic, then you can leave your comments in the comment section, and for regular updates don't forget to follow us on our social media handles.